And now I would like to welcome Bernd. Bernd is one of the heads of NETWAYS in Nuremberg. I'm very glad that he's here today, and he's going to talk about Logstash and so on. Thank you. Thank you very much. Vielleicht müssen Sie auf Kanal 2 für die deutsche Präsentation reden. But I'm going to do English now. I have to make sure now that nobody's going to fall asleep after lunch now. Thank you very much for inviting us. Thank you, Matthias, for making sure that I can have a presentation here today. We are talking about Elasticsearch, Logstash, and Kibana today. I'm going to try to speak slow so it's easier for our interpreters here. I'm going to try to be slow. And if I'm not slow enough, please just throw things if I just am too fast here. Okay, so what is this about? I'm going to introduce myself first. As we've heard before, I'm the CEO of NETWAYS in Nuremberg. I'm very active in Singapore, and I'm very much interested in DevOps days, and those who want to follow me can do so under the hashtag #GetAsh. Our company, NETWAYS, we do open source. We are an open source service provider located in Nuremberg. This is about an hour and a half by car. Sometimes it takes 5 hours, always depends. Right now we have 45 employees, and like I said, we do open source management and also everything that has to do with open source data centers. And of course also custom open source solutions. Our products that we are really working with are for monitoring and many other things like open sourcing, monitoring, and so on. We have a lot of puppets, automation, and also those are really the focuses of tools we use. And that is really everything I want to say in terms of marketing. So what is this all about? This presentation today is really exactly what is happening before monitoring, what can happen before monitoring, really getting all your logs together. It's not really about correlation and all that, because this is something that really can be found in different areas, but it's really about getting log information that's a little bit different than active checks, really, and how can you really gather them. So I'm going to start with that. I have some demonstrations here as well, and I hope that they are going to work. Of course, there's always a risk if you want to demonstrate something, so it's always a risk that it's not working, but let's give it a try. So what are logs? A very important difference here between the structured and unstructured flow of data is that logs really is something that has a timestamp. That's what they have in common, but then really logs aren't very fun if you don't have a timestamp, and then there's also information on top of that. So it's just the flow of logs that can come from hardware, software, and so on. And as I mentioned before, the common denominator here is the message that I have and also the timestamp, but it's very, very difficult to work with unstructured data here. So the main difference here to events really is that you need to have a structure in that log. So really having log information and then attributing them to attributes here. And I'm going to go back one slide to show you that. So if we have October here, if we have a message, for example, receive disconnect, if there's a technical message and you need to structure it, then if you have an event, you can really say, what is it? You have time, you have a process, you have a state, and then just everything you need here. So that's really important, the client, of course. So this is really a very important approach to understand this flow. So really what happens here is you have logs that you know where they are, you know that they're happening, they are being structured because you do need that structure in order to analyze them later on. And then you really use the analyzing tool, and then you can do a certain action with it. So whether that's monitoring and triggering something, or also just triggering something in general. So really the main point here is the aggregation of logs, creating events, and also just structuring this data. And that's really what this is all about. We are also talking about analysis here, really overall how you can analyze this data and really just work with that. It's not about correlation. because that can really be done with other tools as well. So what do we have here? What kind of tools do we have? I'm sorry, this was a little bit too fast, so let me go back. There are a lot of different add-ons that you can use here, where you can do monitoring on logs right away. You can use event consoles here that can work, and also there's some common area here where you can have very different ones. ELK, for example, is one that's very well known here. ELK was really created because Logstash was its own project first, then it was bought by a company, and then the developer, then there was a different developer before that was doing Kibana, before that was the other tool, Elasticsearch, Kibana, and so on, and that's really why you have ELK stack now. This is what the basis is here. There are some other tools here, Graylog, for example, that I would like to mention also, so please don't start surfing right away, because I need some bandwidth for my demonstration too. But then afterwards you can have a look. Graylog, for example, is a very, very good tool. And that's also from a German company as well, but now also Graylog, founded in Texas, now has it in Graylog, now is also very strong when it comes to user authorization, accessibility, and so on. So ELK really has so many different channels, and that's really its strength here, and that's also why this presentation is based on that. Then we also have Fluent, and then we also have 5,000 new projects every day. So ELK stack, this is really what it's all about, and I would like to talk about the architecture and installation first. I'm not going to do the installation guide today, but I would just like to show you what it really means to install it, and also what it can look like. Okay, so this is really what it looks like. This is the big picture here. What's the log infrastructure here in principle? So I have several different shippers on the left-hand side. You can see that very well. So that really means that's where the log's coming from. That can be triggered actively. If you have hardware, for example, that needs to go to a syslog, that a lot of them can do that. If you have looked into that before with a switch, and if you write a syslog, then you can realize that syslog is a syslog, but every provider has their own one. So what I can do is I can have many different hardware devices and write syslogs, but shipment can also be that you see that a log error and then just move it from A to B. So then you can use the whole thing, and that's not an architectural must, but it's very much recommended. You can then use the message queue as well. So in this case, I'm going to use Redis, because that is one of the ones where you can put something on the top, you put it in, and then you take it out on the bottom. So the advantage here of that log construction is that the other part, the indexing and then also evaluation and so on, you can work on that. So I have to make sure that there are no logs lost. So in this case, the message QA is telling me, yes, I'm working and saving all these logs, and then you can also scale them. There's a mechanism for that. So if I work in a big environment, for example, and I do that on a daily basis, then I really have to think about how I can split up this data, and that's why this message queue is really, really good. It's a good way to actually do that with the data. So Redis is just an example here. Of course, you can do that with Kafka or RabbitMQ and so on. There are so many different ones where you can do that as well too. They support it also, but this is the smallest one, and that is really the C program that just works very well. And then this data is in this message queue, so some kind of shipper brings that and says message queue hooray, and then saves it there, and then after that there's an indexer. The indexer is really in charge of saying that out of all this log data that's there, I'm going to really have a structure here and want a database for that. And that database is Elasticsearch, and this is really where everything is saved, where you can look for it later on through a web interface with Kibana. So what is Logstash? It's one component out of this whole thing. So Logstash based on JRuby. And you can really think of it as a pipe on steroids, really. It's a pipe that is saved as a software, and then you can just use any type of channel, and you can really write to a channel that you want. So Logstash doesn't save. It has input, filters, and so on. It can delete things, discard of things, and then it continues writing. So it's very important. It doesn't save anything. So there's input, filter, output. So really, that's really what it is. This is really very basic here. And then there's a lot of different plugin options as well. It's a single file deployment. So there are many different inputs and outputs. What's important here is that I would like to check this in the end. So please remember all of this. I'm going to check if you remember everything in the end. So what really you're supposed to memorize here is that it's just a lot. So I can really just have so many different options here, and that's why it's so charming. It's very important to understand, but it's also important to understand that you can just find that information out later if you need it. Okay, so what does a Logstash look like? It's a single file deployment. You can download it. With Logstash, there's something else as well, but for this one, this works very well. So you unpack it, you put it to a certain location, and then you say agent file, and then Logstash just works. That's all you have to do. Single file deployment, very easy. Of course, it's changing. You have to be open and honest here. So if I have a lot of data, it is changing, but then it needs a little bit more memory and so on. But the configuration itself is very easy. The software is very clear. And then with this configuration and the input and output and filter, as I've mentioned before. So Redis is very similar. For many different distributions, there are packages, and with these packages, you can just use them. Redis, I would just like to say 2 to 3 things about that. It's a very NoSQL memory database, and there is an option to pursue it, so that way it is being saved differently. I can also replicate it, but the basic idea is just a long list, and I'm just going to write my data on that. So that is very, very good, and it's also very simple, and that's really what's charming about it too. The construction is simple. Again, in this case, if you don't take it out of the packages, you just install it single file, and it's working. And again, it's very important that overall Redis doesn't bring any security here. It's open, and you can have a shared secret, so not everybody has access to it, and that's what I recommend also. That can be found very, very easily, and it could be very interesting what's actually there. So those of you who are using Redis, you should really encrypt it, and that is really worth a while. Maybe I should have asked this question in the beginning. Who knows Logstash? Who's using it? Okay, so I still have a mission here then. Okay, Elasticsearch here, to just finish this up. This is also a single file deployment, and this is really something you upload. It can be on the same server. In the architecture picture we saw before, and we're going to see that again. It can be anywhere. So on principle, that really doesn't play an important role here. So it's a lot of different components that are running here, and then they're just being distributed. So now let's get back to the picture of how do I get the logs in there. It was a little bit abstract up until now, just so you see the big picture of the whole presentation. But the question is, how do I get logs in my Logstash? So here the basis is we're talking about shipping again. So I'm saying that I want to read data somewhere, and then I want them in my Logstash. So what do? There are many different things. I can do that with Logstash itself, but Logstash is a little bit slow for shipment, because you can see there are some it just needs a lot of storage here. Then we have the Logstash forwarder. That used to be Lumberjack, and now it's called Forwarder. And the protocol is now called Lumberjack. And maybe in a year's time they're going to change it again, but that's what it is right now. So, of course, we also have the option to really use syslog as well. I can also use gelf, that's the Graylog one format, and I can do a file read. So this is the easiest input here. That's what I showed in my configuration as well. I have an Apache log, I sit on that, and then they are actually taking care of that, transferring the data, even the ones that weren't transferred before, last state, log rotation, and so on. This tool is really taking care of all that. I don't have to do it. And then there's also so many different other options as well. So what's the configuration like? Can you read that? Is it big enough? Some are saying yes, some are saying no. Maybe you just need glasses then, I'm not sure. But I think it should be good enough. So configuration itself, let me move a little bit. This is what it looks like. You have input, output, and it's very simple at first, and then there are different types here. So when we're talking about input, what you see here is the input is a file. So I take a file and I say, well, this has a type. This type is then something that's not specific. It doesn't have to be Apache, but I just give it a marker. So then if I process it later on, I can say, well, this is a Apache, for example. So it could also be a Web Server 5. So this is just a key, sort of, so you can identify it later on. Then we have an output here, that's standard out debug, and that's really that everything you have on the left-hand side is on the console then as well. That's not good for production here if you are copying this example. And then I would say it could be another output is Redis here. Redis is on the same server as well, and you can also give that a key, so it's Logstash Apache. You also see that there's one input and two outputs here, standard out for ebug and then also Redis. So that can be so many different ones. I can have one input and I can have 10 outputs at the same time, but I can also have 10 inputs and one output. So that really doesn't matter. And that really means that all these objects can just be are interchangeable. So now I have this chain, I have a log file here, and you only see one here. We have one access log here in order to save it there. So then what I need here, because right now we just have line by line in this Redis, what I need to do is I have to really put it in my database here. And this is where indexing comes into play. What I need here is I need Logstash. I need the same component. I need to say somebody has to take it out of Redis, and Logstash then has to filter it and put it then in the database. So Elasticsearch has to save it here. So at the same time, Elasticsearch is also the database that is using Graylog, that's using Fune. So that's really the standard in this environment as well, but it's really from a search database banks too. And this is really the standard in this environment today. So what is this all about? I have to have this data, and then I have to use the indexer and put it in the database. So how does that happen? Again, I have an input, and now I change it around. I'm saying my input is now Redis because that's where all data is located. That's where I put it, and now I want to extract it from Redis. With this key and with this output, I want standard out. Again, debug, if that's what I'm using, if I want to see what kind of data I have. And then this second one can be Elasticsearch as an output. So what's happening here is exactly the same as Logstash saying I'm taking everything out of Redis, and then I'm going to put it in Elasticsearch. So just to make clear, you understand that I wouldn't need Redis in this case. I could also just read it out of the file and then write it into Elasticsearch. So it's not necessary, but I would recommend that you do that. If you do a little bit more, that you just use that extra step here. So what's included here in the Elasticsearch? All my data is included here. So my data is very, very unstructured because I have not structured it in any way. I haven't split it up in any way. So what I have done so far is I said line log file and then Elasticsearch. So the quantity really has not changed. It didn't improve. It didn't get any worse, but the quality is just as bad. So that's really important here. At this point, you really have to really work on the quality of the data. So what that means is that we have to use this data that we have in Elasticsearch. We have to actually split them up, qualify them, and really see what that is. So we need more than a timestamp and a message. We have to structure it, and we really have to structure that information, and really have to determine what's what's HTTP, and so on, what's the requester, and so on. So what is this really all about? And Logstash provides something that's called grok. Grok, in principle, is the idea of having a log file and then splitting it up in this structure. So you have a line, and then with grok, you can actually define what is what, and then you can process it from there on. One example for that is, for example, I again have a line here of something, some kind of information, and then I put it in this grok, and this is exactly what it looks like afterwards. So I don't say anything like, oh, this the first one is the IP, the second one is the method, the third one is the request, the URL, then we have the number of bytes, and then we also have the number of duration that it took to deliver this page. So this is not standardized. This is just log information at this point. And what does grok do at this point? Well, through this filter, they are using this unstructured line, and then they're splitting it up. So the client has this, the client has this is the method, and so on. And then I can work from there. So in this interface, this really makes it where I can really have a qualification for this data. So you can see that here, this is Kibana from the web interface here. We're going to look at that in more detail later on. But we really have qualified here how often was this IP used in a certain time frame. So I have a qualification of data here, and what that looks like exactly, we're going to have a look at now. So what's very important here is that you can really write those croc patterns yourself, but it makes sense if you already know it. If you don't have that, if you just say, well, I have log files in some way, but I don't know exactly what it is, then there is a croc constructor. The URL is in the slides as well. I'm sure that there's going to be an archive of this conference where you can actually look it up afterwards. And there are two mechanisms how you can approach this. You can say, well, I have no idea what it is. I have some kind of log file from somewhere, and I just want to know what it is. I want to interpret it. Then if you want to do that, you can just use this line. It's a demo data set here. I already copied it in here, but I'm going to do it again. Can you see that? Oh, no, you cannot. I would have continued another 30 minutes if nobody had told me. Okay, can you see it now? Okay, great. So in this croc construct, there are two different options of working with it. There's this automatic recognition here. So you use a line log that I have, or several ones, and then I just say go. And then what it does is it tells you exactly, well, at least it tries to find out what the best croc pattern that's there, which one matches the best. So what is it probably going to be? And then it just says really that really means that it's everything and nothing. So it's a very bad pattern here. But what it does find out is that it's a common Apache log. So just by the structure of the log, it can tell, well, this must be an Apache because I think the fields are here, so it must be an Apache log. So depending on the log, that works well. It doesn't work so well with standard logs. The auto match usually happens or works very well, but if you don't know what it is. But then if you say, well, it's a combined Apache log, then of course it's not helpful. And then you can do the same second thing here with the manual match. Again, you can put the log structure in here. Can you see that? Yeah, you copy it in here, and then you say, well, what I do know is that it's a common Apache log, and common Apache log is a croc pattern here. So what does it look like? So behind this croc pattern, there's this regular terms here, so something that you are just looking for before, so that's already here in patterns. So if we then look like common Apache, then we see that behind this log format, common Apache, there's all these individual parts that are already set here, and these templates are being delivered by Logstash. So what does it look like then? I can tell you, well, I'm going to take this line, I'm going to put it in here, so I think it's a common Apache log, and then I say go. And then what we see is how it is split up here, and it's telling me, well, this is HTTP, for example, requester, timestamp, and so on. All this information that's important is already structured here. And then it is just a Logstash. So what does the configuration look like in Logstash? As I said, we have a log, for example. Ideally, we know what kind of log we have. We know what an Apache is, and we know what kind of log file it is. Then I say, okay, I have this input, the index from before. I worked on it again. Again, I have to read it, and then I have a filter on top of it. And then I say, well, if you are Apache access, then I'm going to use the key that I used earlier, just so I get the right information out of this queue, because this queue could also contain other information, just other information on top of it. Are you still understanding what I'm saying? Well, I think most of you said yes, so I'm just going to continue. So it's very important to understand that I'm going to use that key that I remembered earlier, and now I want to work on Apache logs here, because there could be postfix or MongoDB logs in there and so on, but I don't want to look at those. So what I want to do is really work on all this data that is worked with Apache logs. So that's why I take it out, and then I want to split it up with the croc pattern here. So with this Apache log, that's what you can do. And then they are being structured, and then they are being saved in Elasticsearch. So another example here is that you can use a filter that's called GeoIP, and with this access log, you can actually see every single line that has an IP. You can get all the geo information and add that. So really, Logstash has this GeoIP and tells me, well, this IP address is probably going to be in this network approximately. And then what it does is it just takes every single line. So every Apache log line, you get then the GeoIP lines as extra information for a lot of data that's very CPU intense. But of course, this really does make a big difference in terms of quality later on. And of course, I can do that with a very easy analytics tool because that is real time here. So every time Apache Logs is producing this, they are being implemented with the shipper tool, being read, and then I can use them here. So I can have access log data with the GeoIP, and then afterwards I can have a map like that. Kibana provides this as well, and then I can see where is it coming from. It's very, very simple. It's very easy to do. All I need is this config snip. It's not difficult. This is the whole configuration you need, and then afterwards with Kibana, this is what you get. And then what I have overall is just enhancement of my access load from the GeoIP. So what kind of interfaces do we have? This is really the part where we have all this data that was shipped from A to B. Now we have it in the message queue, and now it's in Elasticsearch in the kind of format we want it to be. And of course, for us, it's only Apache Log. But of course, there's a lot more. But just as an example, we use Apache Logs. So now I want to look at the data. It's already in here, and I want to have a look at it. So in order to do so, there is an interface here for Kibana. That's what it's called. And what it does, it just uses all the data, and it makes it where you can actually look at it and read it. And I'm going to demonstrate how to do that. The Apache log data that I have in the system here, they write in here, and I just have to find the standard one, and you can see exactly what it's doing with this data. With these panels up here, what's a standard here is exactly all this, so you can really see this full view here. I can see all the logs here, and that's exactly what it is. So that's the file that I loaded here, and now I already gave it a qualitative factor, and that was by splitting it up. And now I can, and I don't have to do anything for that. This is happening automatically through that feed mapping. I can say how are the agents split up. So I can see with this log file right away, well, who is that? Is that Mozilla, or in this case, it's check ADP. So really you can see if it's at number 5, for example, you know you really have to do something for your search engine marketing, which is the case right here in this example. I can look at all these different basic metrics here. So all this is already here, and you can work with it at this point. Right here we have a few dashboards included as well, so you can really see events over time. You can see at what point in time it was very busy, for example, and you can also have traffic here, so how much traffic is on your website, and so on. So what was my response like, and so on. So it was 200s, for example. So you can really see what is going on, and you can just visually see what is going on. What's very good about this at this point is that it's, especially with the GeoIP, is very, very good. If your setup has some kind of power, and you really have to say that that's really what you need here. If you work with a lot of web server data, then and you have the problem that you have an attack, for example, or a DOS attack here, then you see that with Kibana very, very quickly. You can see where they're coming from, what page they're on. And if you do that with Perl, ABK, and so on, then of course the attack's already over by the time you found out what it is. And here you can see it very, very quickly. Do we have a question? I think you need a microphone.
Well, the data you've just shown there, are they in OPEX, the raw format? Can I use the GeoIP to export them and send them somewhere, or are they only accessible through the web access? Well, there is an API for this. We'll get to that, but in principle, the data is in Elasticsearch. It's in the database. But where the output is, you can also define another output, like write them in a file, like take 10 inputs and then put the output in one file. It doesn't have to be the database. Only Elasticsearch database is a standard because people say, I want to do something with the data, but you can take the data from anywhere and write it to wherever you want. So what Kibana does is like a residual query to get the data that's left. You can do that with curl or another program as well, take it out of the Elasticsearch. We'll get to that when we work with it. So the graphic analysis is not a must. So here you can also see what can I do. I can define my own pedals. So if I started my own dashboard, for example, I can do that as well. I can combine elements as I want. For example, here I add a pedal. I say, what do I want here? I want to insert terms. I can insert them. I don't want to do it with the Kibana config because it's a bit too complicated, but here I can just insert something that I want to evaluate, like the P version, put it in a separate list, and this will then be inserted here. It's loading, but now here I can see the HTTP version that people use. So Kibana has a lot of functions, but you have to build your own dashboard. I mean, Kibana is basically empty, and you take all the data that you want and you combine it, because Kibana doesn't know what Apache is. Kibana is just taking data, and you have to make sure you know what data you want to look at. But it's very, very flexible, like in what way you want to present it. So this is a new Kibana version. What you can also do, you can work with S-flow data. For example, you have your S-flow data from your switches, and they can go through Logstash, and then in real time you can see what's going on in my network. So here in this example, I can see that the traffic per source, see where the traffic is from, which one is the most active IP, which one is the most active port. Here, 3306 is the second most active. How many megabytes are they sending in a certain interval? Here we have a time frame of 15 minutes. I mean, you can open the frame or widen the frame, but if you have a 4-hour analysis and there's not enough power in your system, then of course you get a problem. I mean, having a 3-hour traffic detail with many terabytes of data, I mean, you need the hardware for that. On a respiratory file, I wouldn't do that. Well, the question is it worth it to you? I think it's worth it, but everybody needs to know for themselves. The charming thing about the interface is, let's take a look down here. You can see down here, I hope you can see it, which ports were used, what are the IP addresses, there's a line graph, what's particularly active. So up there I have the source, down there is the destination, and there you can see where is my traffic going, where is it coming from, where is it going, who is active. Here we have the VLANs on one spot, so I can say, okay, this is my overview, but I only want to know about 3306, so I want to know about my SQL. So I click on the bar chart, didn't hit it. Then this is being added as a filter for the complete dashboard, this port. So the data is now being refreshed, and now we're only on source port 3306. So the complete dashboard has adapted, and it's only showing my SQL now. So I can easily see which VLAN is particularly active with my SQL. So this is a filter function, really. So my data is being analyzed instantly. So my VLAN 7 is very active, has 2.3 megabytes in the last 15 minutes. Through MySQL, so I look at it, and then all the other objects are based on this VLAN. So which port are they sending the information to? Which server is this? Because I can identify it easily. There's an IP address with it. And then I can see, well, where is all the data going? What's the configuration, source and destination? So source, port level, IP, I can tell you exactly where data is coming from and where it's going. And it's exactly the same mechanism as the Apache log, but the difference is that we're entering S-flow data into the Elasticsearch, and the dashboard you have here, it costs you about a day to make, because of course you have to, well, put some work into it. Kibana does not know anything about your network, but this is worth it because you can save your dashboard and then you give it to your colleagues and then everybody can use it. I think that was the question. You said something about the data is called escrow, netflow, or what's coming from the switches. What we're doing is S-flow. There's also netflow. There are different ones. There are also different kinds of S-flow. So that's the negative side. But it's not Logstash's fault. This is where the hardware producers come into play. And so what agent can I take to get it? Well, you can use a switch as an S-flow destination, and set an SFlow target. So like my Logstash server is my SFlow target with the IP port, and then I have an SFlow input, and that will chop up your SFlow input into the database. So this is the list of inputs and outputs that there are. But in principle, it's a switch configuration. SFlow target is Logstash. Logstash input is then SFlow. It's filtered, and then output is Elasticsearch, and then all the SFlow data is in Elasticsearch in the end.
Okay. Ich gehe wieder zurück zu dem Slide Deck. Neben dem Interface gibt es, und da war vorhin auch die Frage, eine API.
Well, there's also an API next to this. So there's a REST API. I can do data querying. I can have any data set with a curl or in any language you like and look at it. I can manage charts and indices. So all the data you get is being saved in certain indices. So I want to start a database, for example, which you can also drop later. So you can have a shard and delete it. For example, I want to delete last week, last month, and you can also do manage warm-ups. So you can work with certain areas of indices, like warm up the cache if you want to work with it a lot to improve searching functions. So what does the API look like? I have a curl command here just to show you a little what we had in this dashboard here. Any command you are, wherever you are in here, you can use it and inspect it. And you can see the curl command that was used for the Elasticsearch. For example, here's the curl command to get it out of the filters. And if I copy this into the terminal, I get this turn count that I had as a graphic image as a JSON element. And you can do that with any element. There is a very detailed source language. You can do a lot of aggregation. You can really do big data with this. You can really dig deep, but it's very well documented. But the API is powerful. I mean, you can say, I want to do something on the surface, or I really want to work with the data in a programmatic manner. So you're very flexible in working with the data, really.
Okay.
All right. So what does monitoring look like? Before I get to the part of how to work with the data, of course you should also be looking at the stack, because in principle there are 2 or 3 processes that you really have to keep looking at. If it's the simple basis, you have a Resist, your Logstash, Elasticsearch. If you have got more that you want to save, then you may have more Elasticsearch nodes. The data escalates. They have their own software cluster. So it's looking at the, this is taking care of the replica creation, but of course this has to be monitored. You have to make sure that there's enough space on the drive. I mean, as usual, when you're working with files, it's always good to have some space. Storage is a topic, but of course this is all basic in monitoring. I mean, monitoring a stack is very simple, and in the end, you can use one of these commands, no ping, for example. You see it is on the surface, it's a cluster running. So this is a node name I have here. I can have several nodes in one cluster, and then in this Elasticsearch, the requests are being split up and the objects are being split up, and this is very structured. For the management and monitoring Elasticsearch itself, there is its own interface. It's Elastic HQ. There's a commercial version. Elastic HQ is an open source variant. There's also one you can buy, but I can take a look quite closely at my monitoring status. So here you can see it. I can connect and see how many indices are in there, how many documents, how many lines are being loaded. The demo system has been up for 4 days. It's always working with the same Apache log. It's a bit boring for the system, but it works for demonstration. So there's already 1 million documents, and 561 megabytes of data has acquired so far. And I can keep the, with ElasticSQ, I like have an overview. So like memory consume, this is something I can keep looking at. I can look at separate nodes, looking at performance, garbage collector, for example. Everybody who once had a problem with Java, he will know this, or he or she will know this number, and we can keep looking at our Elasticsearch nodes. I think it's important that you know this exists, and I mean, with index management, there's a lot you can do, but it's important that you know Elastic HQ is an option that exists. So how to continue? Integration, Nargos, Icinga, and CheckMK. So what we talked about now is that we have a log, we put it somewhere, we have Kibana to look at it, which can be very time intensive. I mean, just to be clear on that, but you also have the option to pick out the data you really want, and maybe you want to get the data into monitoring. So in real time, I want to have a data flow, and not every 5 minutes a log somewhere and then looking for a pattern somewhere. But I want to make sure that every log coming from somewhere, I want to find a pattern in those. And if there's a match, then maybe I have an error. And maybe I want to react to that. So how to do that? You can take all the data and do an Elasticsearch in real time. I mean, you can look for facilities regex in programs. Every log file can be searched for an occurrence, and as an event, this can be forwarded. So with a Icinga setup, this Icinga setup is something like this. So the standard output that Logstash has is still the old and ugly command pipe, but it works. So the indexer is looking for a pattern in the log file, and it says, as soon as I found something there, I will give an alarm to the monitoring solution. So what does a config file look like for this? In this case, we have the Nargos alert. We have a random input coming from anywhere. I mean, for this example, it doesn't matter where it comes from. And then I want to say I want to start with working with syslog. So I'm looking for a grep. So there's the grok first, telling the system that you're working with that this is syslog. And now I want to search the syslog, because there's an error in there. And when there is an error, then I want to manage that and have an update with this. So if there is a pattern match concerning error, I want to add a field. For example, then I want to add, you find a Nagios host, so you can take the variable source host. So for example, you have a service, and you can automatically add this source host to the runtime, and you add it down here. So which host, which service, which Nagios level do we have here? And then through the output, we're giving it to the Nagios. For once, I want to do the Elasticsearch and have the data in there, but in Nagios, I just want to use it to put it into the command file. And then the alert does show up in monitoring. So what does happen? All the data is being filtered. As soon as a pattern error occurs, a certain host, a certain service has a critical tag, and then it comes up in monitoring. Sorry, I forgot about the microphone. So this is pattern alarming with data input. But there's also the, or is there the possibility to do that in a later stage, like once I have evaluated the data? For example, I have an Apache log and I want to have an alarm if the ratio between 200s and 500s is at a critical level. I mean, that would mean that I have to do Elasticsearch. Yeah, you can do that in Wind Console, for example, but this tool cannot do it. It can do basis aggregation, simple things. But in the next example, we'll get to. Let's continue for 2 slides, and let's hope the question is then answered. Well, this is something that you cannot do with checklog or logwatch or something. Well, yes, it is, because it's real time. Because with this log file, you keep looking at the log file, and it's very unperformant if you have like a terabyte of log files and you keep moving them back and forth and opening them. So if you have a lot of traffic on your website, for example, if you have like 300 to 400 web nodes looking for error, then with a classic check, this will be difficult to do. I mean, somebody will say, yeah, I've done that, and I'm sure it works somehow, but it's a tricky one. And here, even on a very large scale, this works because nothing is being saved on this level. I want to look at all the logs in real time, and only if there is a certain pattern, then I want to work with it. Otherwise, I'll just let it run through. I mean, this is a different approach, but this is quite charming because you can see instantly when something's happening. And I mean, this is a very simple example because I keep saying syslog and error. Well, this is not very sophisticated, but I mean, of course, this can be adapted and deepened. Well, you said in Kibana, you can see very quickly where there's a DOS attack. I think this is something where you put, like would have an alarm. Well, yeah, but I mean, you're not sitting on your Kibana, but you're sitting on a monitoring system, and there you get lots of monitors because something's going on, and then you take a look at your Kibana and you see, okay, my load is going up or my traffic. I mean, I know many environments, there is like an error or a hardware problem is hardly any problem at all. It's just about metrics. It's about, has my gigabyte traffic like changed by whatever percent, whether they check for error or not, it doesn't really matter. I mean, they're just looking at the metrics. But I mean, you're not always looking at your Kibana. So one way you can process it, because Logstash is not doing that, so you look at the event console, so Matthias, and probably 90% of the people present here are better at this than I am, but taking this data that I've collected, of course, I want to also be able to process it in the event console. So one thing I can do is you can enable the syslog server. I hope that I did spell it correctly. Anybody disagrees? Okay, sounds good. Nobody yelled. So you can activate the syslog server. There's also a version with TCP. And then you can send certain patterns to the event console. So we're looking at the same example. So you take a syslog facility in this. You have patterns, and you look for Logstash, whatever. This is just an example, and then you shoot it directly into the syslog server from the event console, and there you can do a correlation process. So here you can say everything that matches to error will always be sent to the syslog server from the event console, and there I have a correlation, and it says, well, if you come more than 500 times, then I want something else to happen. Because the event console, as far as I understand, doesn't save anything, but it just does a run through, but also does aggregation. So I think both tools in combination could be a nice way to go. Like the real-time analysis, pattern match, and then also the correlation, and let another tool do that. Well, I'm already close to my conclusion. Maybe there are a few questions. The charm in the solution is in the variety of inputs and outputs. This is what makes Logstash special and makes it a good module to work with other tools. Elasticsearch is an excellent database, very high performance, but it's a product you really have to, well, get to know. I mean, I have this presentation, so I can write what I want, and in my presentation everything is correct, but when you have 5 Elasticsearch nodes and terabytes of data, then I guess one Elasticsearch stat could not be enough. I mean, maybe then you also need to look at the search files. But if you have a standard setup, if you have large files and the standard setup won't work anymore, you have to really get into it, and because it's a complicated technology stack that needs to be managed. It is very flexible. Sorry, it's the wrong slide. And the second point is you're always collecting everything. It's not the approach that maybe a checklog file or other tools have. I'm looking for pattern X and pattern Y. Maybe later I would, but the approach is I am collecting everything that comes in as log files in my company, and I stuff it all in, and then I see whether I can use any of this. Because the analysis with Kibana, that's really interesting when you see that in the patch log something happens. Then you take a second log in the interface from the firewall, from a syslog, or from a node balancer, and you see different systems in correlation, and then you can say, I mean, you can contract different sources from the log production, and then you come to different sources in the analysis. For example, there was a Puppet run or an Ansible, and suddenly my load is going up. Then you have a second source. Somebody uploaded a package, and PHP something isn't performing as it did before. But of course, to get there, you need to have different log sources, like Apache log, DAB, and so on, and you have to analyze this together, and that is where the added value comes from. This is what makes the solution special. So this is basically what I have to say. Maybe there are 1 or 2 questions, and maybe I can give you the answers as well. Well, can you tell me a bit about housekeeping? Because log collections often lead to issues with that. Well, housekeeping in this case would be Elasticsearch as a standard. This has changed a bit. There is a week-wise index. Like every day or every week there's a new index. Maybe you can work with it with an Elastic HQ, and each of these indices, like each of these daily reports, can be deleted very easily. So the housekeeping, this is really a monetary issue. What you think housekeeping is good housekeeping? You could say, I delete all the housekeeping, all the indices that are older than whatever, and that's your housekeeping. But there is no detailing about what data you want to keep. Of course, you can take your data and say, I want to have all this Apache data put into one log and the other data into one other log, and then you can separate them into different index retentions. But the system doesn't delete anything. You would have to do that. The system keeps saving until there's an out-of-memory exception. But if you want to work with different retentions, then already while you're writing the system, you would want to make sure which kind of data does need its own index group. And it's a simple attribute that you insert while writing the system, and then it's all in there. It's very simple. You just have to keep it in mind and do it. Well, you mentioned that there are so many input sources that can be processed. You also said that Reddit or message queue is quite useful. But with syslogs, I cannot write directly into Redis, which is best practice. Is there another Logstash in between? So syslog writes to Logstash, and then that writes to Redis, and then back to Logstash? Yeah, pretty much. Depending on where the data comes from, just as you said, you cannot write from syslog to Redis, so we have another Logstash in the middle, sitting before the Redis, as we had in the first shipment example. So that's reading the log file. So it's coming from any source, and it puts it into Redis. So what this Logstash does is simply store the data in Redis, because the advantage then is that this Logstash component that is before the MQ, you can always activate or deactivate it and decide, well, I don't want to read this log file now. But if you're between the reading and the index and there is no cache, then you cannot even shut down your indexer and try something, because you have the problem that data immediately gets lost. So this abstraction example is in place. But you're right, you need another Logstash in place before the Redis. This is a good example. I would suggest that this is also quite, it depends on how tricky your system is really. I mean, on a personal note, what RAM disk, what file system types are better than others? For Elasticsearch, you mean? No, to get the like optimum system in this respect. I'm not sure whether I got the question right. You think where the software is running or where Elasticsearch is getting software from? Well, I'm looking at the indexer. I mean, actually, in my case, everything is on one system, just to try around. Maybe 300-400 log files coming in. That's quite big. But maybe I should start a system like from scratch that can be adapted later and expanded later. Well, my experience is there's always a group of logs that you analyze a lot, and there's a group of logs that you analyze rarely. But once a year, somebody comes from revision and says, I want to know this. So I would look at that from the very beginning and find out which indices are important. So if I do scaling with Elasticsearch, and I want to have a certain number of charts and replicas on high performance servers, because I know there's a high search frequency, I can use SSDs on these. But maybe I have other data which is being overwritten all the time, but I don't need it so much. I mean, you can store it on anything slow that is very big. So there are two possibilities. When it comes to sizing, you either know what's going to happen to the logs later. The other possibility is that later I can take and regroup indices and maybe move them from one server to another. And Elasticsearch is clever enough to collect the data from different sources, so it knows where the data is in the system. An unfair answer is more SSD, more money means better performance. But I mean, what Elasticsearch does with this mapping and the indexing of data at runtime, the request can also work on a classic mid-class server. The request time is, well, it's not like parsing a case, but it's like building aggregates, and the database can do that. I mean, at runtime, you don't need a file read for everything, but there's already some indexing done. And the second thing you can do is warm-ups. So, for example, for certain segments that I know are very large, but they're index relevant and search relevant, I can just warm up my cache. And then the index is being programmed accordingly, and then it can be read very quickly. The experience is that usually the data is unbalanced. So maybe you have 2, 3 big servers with SSD, but you like put everything in there. But you also put things on the expensive SSD database that nobody ever looks at. And I mean, this is something where you can save money on, really. So what I need, I have 2, 3 gigabyte, terabyte. I have really quick things for things I really need, and the rest, well, I store somewhere else. And then maybe it takes Kibana 2 minutes to work with, but still. Maybe I can repeat the question if we don't get the microphone. I repeat the question. The question was about authentication and authorization. In the open source variants, there is nothing. In the enterprise version, there is shield. In principle, there's nothing. So if you want, if you access the Kibana, you can see everything. We have written our own proxy, which can do that. It does nothing but shield, so we have reprogrammed shield or copied it, but it's not open source because it's not done yet. But as soon as it's done, then we'll put it on open source. It's a shield replacement that works a bit with authorization as well. So in this solution, it's something that wasn't really taken care of, but everybody can access Kibana. You can abstract it a bit, making sure there's certain data. If you don't want to have it in a really fine filter, you can say that certain data comes to certain elastic nodes. But otherwise, that's it. Graylog is better in this respect. But I want to say that this is also a strong side of this approach. Of course, security is something you need to look at yourself, but maybe the charm is to look at log files that in analysis or correlation you would usually not look at because some other department does that. But in storage log, in comparison to an Oracle log, I mean, can be very interesting. The question is whether internally in a company people want to do that. But the advantage is that you can see so much and draw all these correlations, really. Is Logstash multi-threaded? With the Java that's underneath, yes. It uses the hardware quite well. When you have an evaluation, like Elasticsearch of data that is already in the database, like in Oracle something, if they were to be implemented, how would you do that? I mean, for example, I have my Oracle database and they're all filtered nicely in some archive, and I want to use this archive with Elasticsearch because I can use it to search for everything from the front end, and I want to, well, get into that. So I cannot access this with the SQL, but only through the front end, which will then implement it. Would there be another Logstash in place beforehand, or how would you build this? So we have data in a relational database. Can we look at it? No, the question was, I want to look for a certain field in Elasticsearch because it's a very good search engine. Well, then you have to just load it in Elasticsearch. You can export the data from the Oracle database, CSV if you like, with a certain input. I'm not sure. There is also database inputs that can do that. They're not in the standard package, but there are community publics for Logstash which can read out of a database like tables in an SQL query, and then you automatically put the data into Elasticsearch, and then they're being indexed. If you do not want to correlate the data, so if you're looking at the Oracle set and want to combine it with other data, no, I have an archive. And the in the archive, it's only the data in there that's interesting to me, but with Elasticsearch, which is quite quick, I want to look at the data from the outside. But you don't want to correlate the Oracle data with another system. No, I don't need to. Okay. So are they normalized in the database already? Yes. Then the database is actually quicker. So I would have to find something else to look at the data. Well, I mean, Oracle can give you the data in a normalized data model, and they can also be indexed better in Oracle. You can do it with Elasticsearch, but it doesn't look as good. I mean, Oracle Enterprise, there you would have nice images. I mean, I would export the data from the Oracle into CSV, then import it into Elasticsearch, and with Kibana you can look at it. And of course, you don't have to think about the indexing in Oracle, or with serialized views or whatnot, because that's a whole new way to work. This is a valid approach.
Hey.
Hallo. Haben die den Durchsatz von großen Daten für Logstash verglichen mit anderen Lösungen wie Kafka? Ja, es ging um Kafka. Es ist unterschiedlich. Kafka ist nur eine Message Queue. Und bei Logstash kommt es auch auf die CPU-Performance an. Also wenn man nur einen Input-Filter hat und dann den Ausgang nimmt, dann geht es wirklich schnell. Aber wenn man zum Beispiel viele Pattern-Matches macht und nach IPs sucht oder sowas mit UIP, dann ist es sehr suchintensiv und sehr leistungsintensiv. Also es kommt wirklich auf die Logstash-Grundvoraussetzungen an, die auf Ihrem System hinterlegt sind. Also im Großen und Ganzen ist Logstash sehr schnell, wenn man viele Regex und Enhancement-Sachen macht mit den Logdateilen, aber es ist schon sehr schnell, wenn man viele Daten hat. Und wenn Ihre einzelne Logstash-Instanz es nicht schafft, dann kann man zum Beispiel skalieren, dass man eine einzelne Message-Queue hat, die auf Message basiert und Revenant Kafka mit speziellen Log-Bereichen, zum Beispiel man hat Redis und Apache Falls, Syslog und Postfix. Und dann hat man verschiedene Indizes, die mit diesen Dateien arbeiten. Also wenn man es so skalieren muss, dann hat man vielleicht verschiedene Logstations mit spezifischen Elementen in der Alarmierungsqueue. Ist das eine gute Antwort? Ja, so ungefähr. Vielleicht sollten wir da nochmal persönlich drüber sprechen. Gut. Good. I think we've done it. Thank you very much for listening.